So in the first lab, you're going to add an ILA core to an existing design with a core inserter flow. As I mentioned earlier, this is probably the easiest way to add a ChipScope core to your design. This lab will give you a chance to use the core inserter flow, add an ILA core, gives you an opportunity to customize an ILA core by setting trigger conditions, and use the ChipScope software to configure your device, set those conditions, and then analyze and debug a simple design. This lab shows ChipScope in its simplest form and shows how easy it is to set up designs, analyze, and debugging. The files and lab instructions are in the zip file you can download with these slides and script. Note that a Spartan 3 demo board is used in the lab, but if you have the finished pinout of your demo board, you should be able to use your demo board with this same design. All you'll need to do is modify the design's UCF or user constraints file to match the demo board you're using. Now, before we show you a little bit about the core generator flow and give you a chance to do a lab of the core generator flow, we want to introduce the PlanAhead flow. As I mentioned, this is very similar to the inserter flow. It allows you to interactively select signals to probe with the PlanAhead software's netlist and schematic viewers. In this case, we see some screenshots that illustrate just that point. As you can see, we have synthesized the design, and PlanAhead has loaded the synthesized netlist, and now allows us to select some of the nodes from our design with the schematic viewer. This is a very easy and powerful way to set up your debugging, and many customers like this flow. We also see that our various trigger nodes are listed and can be managed with PlanAhead. There is also a wizard that walks you through the setup of your ChipScope cores when using this flow, which also makes it very user-friendly. The PlanAhead software also inserts and compiles the cores, besides being tightly integrated with the ChipScope software. Selecting signals to be debugged is very simple. As I mentioned, this can be done with a schematic viewer, but also can be accomplished with a netlist or folders view. The netlist view allows you to see a list of the input and output nets from each level of hierarchy and select which ones you want to add. You also have access to a find command, which can be used to find a particular node name you're looking for to test. The size of each of the debug cores can be easily found with the PlanAhead flow, but also can be found with other flows. Since the cores are added as netlists, given the file extension of NGC, they can be selected and their size determined easily. This is important because the amount of resources will vary by the number of match units you're sampling. Verifying the size of any component or netlist is normally done by right-clicking a component in PlanAhead. This will automatically generate a GUI like you see here, where the number and type of each resource contained in the component is listed. However, PlanAhead will also show you the connectivity of each core in a schematic. One of the other side benefits of PlanAhead is the ability to make effective area constraints. Some customers choose to assign their ChipScope cores to specific area constraints in order to avoid routing congestion or to keep the core near critical logic. However, note that if you test nodes that are very far away from the cores and are assigned an area constraint, then you might incur some significant routing delay. So be careful about placing those area constraints and where you place them on the die. With the core generator flow, the cores are instantiated directly into your HDL. This requires manually editing your HDL to make all the necessary connections to the cores, and this takes more time to build. We will use this flow to debug the same design we used in Lab 1, but now we're going to use the core generator flow and also use the VIO core, and that'll all be part of Lab 2. If later on in the design flow you want to remove the cores from your design, which is what most people want to do, you must comment them out. This process uses the standard implementation process that would be done by any designer wanting to add a component made by the Xilinx core generator. This is not nearly an automatic flow, but does give you complete control over the nodes you want to test, since you can probe inside of the components. In Lab 2, we're going to build on the knowledge we gained from the first lab. We'll add an ILA and a VIO core to the design using the core generator flow. This lab will give you the chance to work with a different flow, use the VIO and the VIO console cores to debug, control, and monitor your design with the ChipScope software, and be able to contrast the flows. A very worthwhile lab. In summary, The ChipScope software enables you to shorten your debugging time by 50% and enables rapid debugging iterations. It also allows you to test your design component by component. ChipScope also enables you to test any node in your design, of course when using the core generator flow, and to test many nodes at once. You can add ChipScope cores at any time, either during design construction or after your design has been made. Each of the ChipScope cores has a specific purpose. The ILA core is used for viewing the operation of your device, and the VIO core is used for driving stimulus to your design and sampling data from your design. Adding the ChipScope cores makes minor impact to the design. It usually enables you to test your design at system speed, since the cores are optimized for both speed and to use minimal resources. You can learn more about ChipScope from Xilinx's homepage. Just go to the CS Pro location specified here on the slide to learn more about what is offered. You can also view the ChipScope recorded demos, access the 60-day license for ChipScope, and review the user guide and other software documentation. There are also recorded demos that discuss how to insert ChipScope cores and how to use the ChipScope software to debug and verify your design. You can also learn more about Agilent's products. Agilent's FPGA Dynamic Probe combines the on-chip debug functionality with the power of a logic analyzer. The labs you're about to complete cover the most essential functionality of the ChipScope software, so be sure to spend some time working with the tools now that you have completed the training presentation. If you would like to learn more about other courses and RELs we offer, including our ChipScope Pro course, please go to the Education Services page. In this course, you'll basically learn all that there is to know about each debugging flow. There are labs that go way beyond what we have covered here, including discussion about the trigger options, data visualization options, scripting options, including tickle scripting to automate data flow, and a discussion about remote access. Again, my name is Frank Nelson. Finally, we want to thank you for listening to this recorded e-learning on the ChipScope Pro software. Thanks for your time and attention, and thanks for your business.